In the previous video, we saw how we could calculate the medians and quartiles using linear interpolation from a grouped frequency table. Now we're going to have a look at how we can find the mean and standard deviation from a grouped frequency table. So in order to do that, we're going to need to estimate a number that we can use to represent all of the times from 2 to 6. For that, we're going to use the midpoint. So that's just going to be, in this case, 4, midpoint of those 7.5, and so on, 9.5, 13 and 18. And then what we do is we say, well, if we've got 8, this is the frequency, sorry. If we've got 8 times of about 4, then if we just do 8 times 4, that will give us an estimate of the sum of all of those unknown times. We know that they were somewhere between 2 and 6. We've got 8 of them, so we're saying, well, that will probably work out as about 8 times 4. There will be as many above 4 as below 4, in all likelihood. So if we calculate those, we get 32. I just need to put these into my calculator quickly. (32), 105, 171, 468, and 252. So what that's given us an estimate of what all of our data will add up to. So for example here, times between 9 and 10, we've got 18 of them, so we've just added up 18, or multiplied together 18 and 9.5 to get an estimate of what all of the times in that class will add up to. Then if we add together all of those estimates, we should get 1028. That tells us what we think roughly all of our data will add up to. So now that we know what all of our data add up to, we know that the mean, or at least our estimate of the mean, is 1028 divided by 90. So our estimate of the mean is 11.42. Always have a quick estimate. Is that a reasonable number? Somewhere in this class, slightly towards the lower end of it, it feels reasonable. If you ever realise that that's not a reasonable number, just check those numbers, make sure that they all seem sensible. You may not know what 36 times 13 is, but you can roughly say, well, it should be about 40 times 10. That will allow you to spot any obvious errors. Then if we want standard deviation, we need to remind ourselves of the formula for that. So if we just remind ourselves, standard deviation, first of all we need the variance. That was the sum of x squared divided by n minus the mean squared. And then the square root of that was equal to our standard deviation. So we need to know what the sum of all of our data squared is first. Returning to this board, that's why we have here frequency times the midpoint squared. Again, we can't know it exactly, but we can estimate what it is. So that's what we've done here. I've got 4 squared times 8. So midpoint squared multiplied by how many of those I have. And adding all of these up quickly gives me each of these numbers here. And then again, I need the total of all of those. Okay, just a quick little side note. We would refer to this as the sum of fx, frequency times midpoint, and this is sum of the frequency times the midpoint squared. Notice when I do this calculation, I'm only squaring the midpoint, not the frequency. I do not have a bracket there. Okay, so now I can calculate my standard deviation. It's going to be variance is equal to 13160 divided by 90 minus the mean squared. I would recommend that you keep this number exactly stored in your calculator so you don't have rounding errors. Putting that into the calculator, we will get a variance of 15.76. Quick reminder, in order to get the standard deviation we need to square root that. So our standard deviation will be the square root of 15.76. Put that in our calculator again. We get 3.97. Again, remember how we can estimate whether our standard deviation is sensible? It should be roughly the mean plus minus one standard deviation should cover about 2/3 of our data. So let's call it 11.5 plus minus 4 would take us up to 15 and down to about 7-ish. So yeah, that would cover about 2/3-ish of my data. It doesn't tell me if doesn't guarantee that I've not got any mistakes in here, but it does give me confidence that my answer is at least sensible. There's no glaring errors in my work. And that's how we can calculate mean and standard deviation from a grouped frequency table.